Okay, good morning, everyone. I'm Silvio Simani, and I'm delivering this course, which is intended for a PhD program of the DAUSY National PhD. And this is an online course, and this is the page of the lectures. It can be reached by following the general page wcube silviosimani.it talks.html, where all my talks and presentations are recorded. And you will find, by the way, the seminar or courses that I delivered for the previous versions of sessions of the PhD. And for this year, I proposed this course, which is entitled Intelligent Control Systems. And I reported here in the page. You have here the link, the complete link. I'm assuming that you are familiar with which are, I think, normal requirements. So the basic concept of mathematics, differential, difference equations, and integral computation. Some basic concept of physics, just because maybe in the introduction we will recall something regarding basic physics, and then because we are talking about dynamic systems, so I am assuming that you know what is a dynamic system, its behavior, practical applications, and also method for analyze dynamic systems in steady state and transient conditions. And then, of course, some basics of frequency tools for the analysis of dynamic systems, especially for the starting part of which concerns the identification of dynamic systems. And of course, the last point is the ability of analyze and design digital systems. Is something that is not really required for this course, because due to the time constraints, we will not meet the development, the practical development, even if I'm mentioning some tools for the design, the practical design of intelligent control systems. So we try to provide, as is reported here, the presentation of the main tools for designing intelligent. Well, intelligent means that is mainly data-driven and model-free. So intelligent in the sense that is able to adapt to the different conditions of the process where you are applying these strategies. And also this course proposes the elements that are used for the design, and in particular we will see in the following different modules, for example, the tools that are used for the identification of linear models, and then the design of an intelligent or an adaptive control system using, for example, the neural network tools that are normal or well-known tools that are proposed. We borrowed them from the artificial intelligence area, and we are using them in for our topics. So the objectives, this is a list of the objective and the knowledge that should be provided by the course. So some basic linear and nonlinear tools for identification and control, and the analysis of nonlinear dynamic systems, and then the knowledge of the blocks for system identification, and a study of complex systems, the interconnections, and the constraints, and of course the knowledge. I will try, or you will see in the first modules that I'm providing. I'm showing some also mathematical tools that are quite theoretical, but for the analysis that is just an overview. But of course, in practice, many of the tools that are proposed in theory are not really useful in practice, because at the end you will see that all the processes are nonlinear, complex, and most of the tools that are proposed here are not valid, because the process is nonlinear. So also the main skills, that is something that perhaps you will acquire not really in this course, because perhaps you need more practice for designing. Well, the design of an intelligent control system requires several hours, so this course intends just to give you the tools, and perhaps in some other courses you will see how to design in practice these solutions that I'm proposing in this tour. So the general program, we have 20 hours, and so this will be an introduction. After this introduction, we will see the basics of system identification, and I will sketch some techniques for the classical system identification, because system identification is the basic, we will see, is the basic for designing an intelligent control system. Of course, we will start from the linear area, from the linear framework, and then we will move to the nonlinear area. And especially when we will analyze the neural networks that represent a main tool for really designing an intelligent control system that is based. So the basic idea, or the principle is called model reference control. So it means that at the beginning you will start from a linear controller, and it's why we will record some basics techniques for the design of, for example, a PID or model predictive control that can be used as a reference controller for the design of a nonlinear controller. So as I mentioned earlier, all the lectures here are available as, so the slides, the slides are, just check somebody is, okay. So we'll find the slides in English, and the lessons that are already recorded and available from our YouTube channel. And so you can, since I received a couple of messages from you that due to the superposition with other maybe local courses in your university, they are unable to attend this online course. So you can listen and watch to the recorded videos that are already available. Well, apart from this introduction that I'm recording and I will prepare in the afternoon, so we'll maybe those of you who are not connected were late in this connection, so they can check here. Well, for those of you is an important point, because as the last year most of you don't require an official examination. I mean, you don't need to pass an exam, so I'm available to give you just the certificate of participation. But for those of you who really need to acquire the credits for this course, so it means that they need to pass an exam, I prepare a Google form with some multiple choice questions. It's reported here. Some quizzes, nothing that is theoretical, but it is needed to understand if you learn the basic principles of this methodology, which is quite important and works for many applications, and so it's quite important. So in this case, I will prepare a form for you with a link, and then you can answer in remote, because it's something that perhaps if you don't understand from the lectures, is something that, so it means that you are, is an issue that you are not required, so it's something that is missing. And at the end of the page, I reported some books, some fundamental books. Most of you perhaps already know these basic textbooks, because they represent some important points in the studies, and so there are some books on general nonlinear control, and also I reported here is something that we will not examine in this course, in particular fuzzy systems, so are not considered in this course, but because we are focusing on directly on neural networks. And then these neural networks are used for the estimation of the nonlinear controller. And also there are several books on adaptive control, and you can see here a basic, this is a very important textbook on system identification, and some other at the end on adaptive or tutorial. I reported here some also basic tools and docs, because I think that most of you are familiar with MATLAB and Simulink, because they represent the most important tools for the design of any system, any simulation, any identification or control for this course. And so I reported here just for mentioning these important tools, even if we know that there are other tools that are used in the academics for the design of other of these dynamic systems and simulation tools, but they are representing something that I'm using for the design of these systems. So I think I can stop there.